Hello guys, welcome once more to Prepclass Physics class online, and my name is Tutodami. In this edition we shall be looking at Waec Physics 2016 question number 6 to number 10, and we shall be taking very important topics that many students consider problematic. One of such is the moment diagram. Many students believe that, when we have movement, I don't understand how movement is done. But generally, we shall be taking a question on movement that will help you to understand that. And we shall also be taking many other topics within the past questions that will clarify a lot of things to you. Don't forget, if you learn something from this video, to click on the like button. We have much content to share with you that will help you to further understand physics. Now, question 6 said, an object of volume 400 centimeter cube and density 2.5 gram per centimeter cube is suspended from a spring balance with half its volume immersed in water. Now, determine the reading on the spring balance. You know, spring balance is used for finding, is naturally supposed to be used for finding force, while beam balance is for finding mass, or chemical balance is for finding mass. But now this is a spring balance suspended. Now let's talk about this now. Now, the first thing to do in this question is to find the mass. Now, you can see the target of this question is to find the mass. Right now, there's an indirect way by which spring balance can be used for finding mass, but generally spring balance is the instrument for finding weight. Now, but weight can be converted into mass. Right now we will refine the mass of this object. Notice you were given the volume and you were given the density, and density is therefore mass over volume. You know that density is mass over volume. So I will use this formula. I will turn it around and find the mass first. So I was given density and volume. I'm finding the mass. So I will cross multiply. The mass will come down. Mass is therefore density times volume. Right? Good. Now the next thing is to plug in the density you were given, 2.5, and your volume 400, and that's 2.5 times 400, and that is 1000 grams. That is the total mass, but that is not the mass we were looking for. Why? Because we were given another instruction. It is suspended on a spring balance with half the volume. Now, half that volume. So the next thing I will be doing is I will be finding lost mass. The total mass of the substance is 1000 mass, but we are told to half the volume. So now finding that means some mass was lost in the process. Now finding lost mass when immersed. When it was immersed in water, some of the mass was lost. So we will find the new mass will now become, now this is 1. How did I get a 1? Because that is the density of water. The substance naturally in the air was 1000 grams, but when it was immersed in water, what will be the new mass? Now, first of all, the formula for mass in this is density times volume. We have said that from the beginning. Now, the density of water is 1 gram per centimeter cube. Then my volume is now halved. That means divided by 2, 400 divided by 2, and that makes 200. So 1 times 200 gives me 200 grams. So the new mass is the lost mass, when it was immersed in water, is 200 grams. So now, what is now the mass left? So remaining mass is therefore mass total minus the lost mass, and therefore the remaining mass is 1000 minus 200, because the total mass from the beginning is 1000. The lost mass is 200. So therefore the remaining mass is 800 grams. So that is my answer, 800 grams. Now don't forget that everything came from the formula density is equal to mass over volume. I cross multiply and I got my mass as density times volume, and that is my mass. And that is how to go about the question. So I found the total mass first, and later I found the mass when immersed in water by dividing the volume by 2, and the mass of water is 1. So I got 200. Then I subtracted to find what mass will remain, and that is just the end. So that is the answer to the question, is 800. Option C is correct. Now let's check out number 7. Number 7 says the diagram above illustrates a force distance graph for the motion of a wooden block. Right? Determine the work on the block when moved through a distance of 5 meters. Even if they did not tell me, I can see it here already that the distance is from 0 to 5. So that's natural, and the force is 20. So therefore, don't forget that this is very simple. This is just a question you will ask somebody in SS1, even in JS2, because they were taught about work. Work formula is always force times distance. Work is force times distance. Although there can be different kind of work, but generally work formula is force times distance. And now what's my force here? 20. What's my distance here? 5. So therefore my force will now become, my work will now become, force is 20, distance is 5, and my work will become 100 joule. Full stop. Very easy. And that is just it. Now that is the answer for number 7, 100 joule. Now let's check out number 8. The position of a body undergoing a uniform acceleration motion was at this 10 seconds, 10 meters per second, and 30 seconds at 50 meters per second on the velocity time graph. Calculate the magnitude of the acceleration. Now, for you to, whenever they say acceleration, you know, acceleration generally is velocity over time. This is very easy. So, generally, acceleration is velocity over time. That means change in velocity over change in time. And the reason why I put a change is because you were giving double of each. That means there are 2 times, 10 seconds and 30 seconds. 10 seconds and 30 seconds. And there are 2 velocity. 10 seconds and what? And 50 meters per second. So we have 10 meters per second and 10 meters per second and 50 meters per second. So whenever you are giving 2 time and 2 velocity, just put a change in the formula. Change in velocity over change in time. Now my position 1 is 10 seconds and 10 meters per second velocity. My position 2 is 30 seconds and 50 meters per second velocity. So now what to do is now to do acceleration is therefore change in velocity over time, right? And that means v2, that's velocity 2 minus velocity 1 over time 2 minus time 1. So my v2 is 50, that's my second velocity here. My v1 is 10, and that's this one here. Then over my time 2 is 30 and my time 1 is 10. Very easy. And therefore I'll be getting 50 minus 10 is 14 and 30 minus 10 is what? 20. Full stop. And then the answer is now 40 over 20 is 2 meters per second. And that is the simple answer to that question. Don't ever go for option A. That's very wrong. Don't go for option C or option D. Those are super wrong. They are just traps. So the simple question is acceleration is always velocity over time. If there are double of each, do change in velocity over change in time. That means v2 minus v1 over t2 minus t1, and you will always get your answer correct. And that is number 8. So let's see number 9 now. Number 9 says at a birthday party. Now some of us like birthday party, right? We like birthday party, right? Now the celebrant pop a cork fruit wine. Now we like that also, right? Now if the cork shoot out on the bottle at an angle 40 degrees to the horizontal and travel a horizontal distance of 4.5 meters in 1.25 seconds, calculate the initial speed of the cork. Find the u. The u is the initial speed. Now whenever you see something like this talking about motion, movement, and there is an angle, if there's an angle in a motion question, that is projectile. This is a projectile question. I know that from the instance I saw it, because I know that only projectile motion has angle. You can see 40 degrees. It is not under anywhere under linear motion. It's not under upward motion or downward motion. That's motion against gravity and motion under gravity. It is only found in projectile. Okay, now the cork, that means when the person opened it, boom, it projected like you shoot a bullet. It went up and came down. That is projectile. Now, how do you solve this kind of question? But the way you will solve it is that look at dimension horizontal distance, and that is range. This thing, horizontal distance, is the mean of range. So that means you'll be using the range formula, and this is where you use it. Range is what? U cos theta times t. Now that formula is the master formula for range. Although there are other formula for range, there's another formula for range aside it, but the other formula that you have as only u, as sine, as theta, and as g, and that won't have time, so that formula can't be used. Now this formula is the formula to be used. This is another formula for range. So there are two major formula for range under projectile. It can be this one, and this one is the one that suits this question. Now we are solving a past question, so we will look for which formula goes for range best. You might want to remember this formula by putting it down in a book separately. Range is u cos theta times t, and that is the formula that has the time. Okay, so let's see. So what is my, I'm trying to find my initial speed. That's my u, because u means initial velocity. So now I have make the u the subject, so that means that the cos theta and the time will go under the range. So range equals cos theta times time. I just turn the formula upside down by removing this cos theta and time and putting them under the range. So range equals u equals range over cos theta times time. So what's my range in the question? That's my horizontal distance is 4.5, and that is here over cos theta. The theta is 40, so that's cos 40 times my time is 1.25, and therefore that will give me cos 40 times 1.25 is 0.98. So 4.5 divided by 0.98 is 4.7 meter per second, and that is the answer. Number B, option B, is the correct answer to number 9, and that is how you blast questions on range. Let's check out number 10 now. Number 10 says now this is the one that I spoke about at the beginning. Moments. Now a uniform meter rod is balanced on a fulcrum placed at the 35 centimeter mark by suspending a mass of 120 grams as the 10 centimeter mark. Determine the mass of the meter rod. Now the first thing to do is to draw a long ruler. Now the length of the ruler that we use in the lab is always 100 centimeter, but now the fulcrum was placed at 35 centimeters. So I drew it this way. The fulcrum, that's the knife, is resting at 35 centimeter. Okay, and then that means it is turning at 35 centimeter. It can tilt this way or this way. So now let's see. Now they said that the mass was placed at the 10 centimeter mark. That means the mass 120 was placed at the 10 centimeter mark. Okay, now what is the mass of the meter rod? That means you have to find a second mass that will help to balance the meter rod, and that is I place it at the 50, and I'll tell you why. Because the full length of the meter rule is always 100. They won't have to tell you that. You just have to know that the full length of the meter rule that we use in the lab is always 100 centimeters. So the mass of the meter rule acts at the middle of 100, and that is what you will ask. The mass of the meter rule will act at the middle of 100 centimeters, and that's 50 centimeters. So I place the mass of the meter rule at 50, and I don't know the mass. Now, don't forget that the mass of the rod is m. Okay. Now, there's a law of moment that says clockwise moment equals anti-clockwise moment. Clockwise moment equals anti-clockwise moment. So now, my clockwise is the first one here, right? Here, that's this way. So, this way. Now, that's this way to you. So my clockwise is therefore, actually, you can use any one as your clockwise. So I'm starting from here. So I'll be saying, what is my mass here? You know, moment is mass times distance. So you will measure the mass here times the distance from this place to the fulcrum. And therefore, my mass at this point is m. Okay, moving to the fulcrum is distance is 50 to 35. That's 50 minus 35. Because moment is all about the mass first times the distance. So that's the mass is 100, 50 to 35, and that is it. Then the second one, that's equals anti-clockwise now. The mass here is 120. The distance from 10 to 35 is 35 minus 10. And that's what you have there. So that will give me what? Now, m is m. 50 minus 35 is 15. 15 meter, 15 mass or m equals 120 is still 120. Then 35 minus 10 is 25. So I have 25 times 120. 15 meter and 15m equals 25 times 120. So 15m equals 3000 because 25 times 120 is 3000. So now divide by 15. So my mass is therefore 3000 divided by 15, and that will give me 200 grams as my mass. Don't forget the way it was said. First of all, draw it perfectly, then put your mass times the distance on one side equals the mass times the distance on the second side, and that will bring you to your answer. Okay, and that gave me 200 grams as my answer, and that is option D as the correct answer. Don't forget, if you learned something from this video, to click on the like button. We have more contents to show you that will better help you understand physics. Until we see you next time, guys, take care of yourself and bye for now.